Okay, hello everyone. Let's go ahead and take a look at our next section, which is called the double angle formulas. Okay, as that sounds, it sounds like we're taking one angle and doubling it and finding out exactly what the sine, cosine, or tangent of that double angle is. And what the double angle is really based upon is based upon the compound angle formulas. So here again are those same formulas that we looked at before and which now you should be familiar with. And the double angle formula says this. Instead of having a plus b, which is here, assuming that a is equal to b, then that actually becomes a plus a, which is the same thing as 2 times 1 angle, which means that you're doubling the angle. So what we can do then is we can actually derive all of these formulas for the double angle formulas, just by looking at the compound angle formulas and ensuring that a is equal to b and add the two same angles. So, for example, we have the cosine of 2a. That's the same thing as cosine of a plus a. And if we go ahead and use this compound angle formula, assuming that this is an a, this is an a, this is an a, this is a plus, therefore this is over here a minus, then we can come up with the cosine squared of a, because these two are exactly the same, minus the sine squared of a, because these two are exactly the same. So now the thing that we also need to go ahead and remember though is that there are other identities that we have, and the primary one is the sine squared of a plus the cosine squared of a is equal to 1. Being that I know that the sine squared of a can actually be rewritten as 1 minus the cosine squared of a, I can actually go ahead and write cosine of 2a in this form if I wanted to as well. In the same respect, if I wanted to go ahead and substitute 1 minus sine squared of a for the cosine of 2 squared a, then I would actually come out with this result here. So what happens then is that if we take a look at the cosine of 2a, there are really 3 different ways that you can express it. This is the first way, that's the second way, and that's the third way. Okay? Now we can do the same thing for the sine of 2a. That's the sine of a plus a. And notice that if we let b be a, and we do plus, then of course this is going to be plus as well. So these two actually become exactly the same thing, which is represented there, and we come up with 2 sine a cosine a. So the sine of 2a only has one particular representation for it, and that's what it looks like. Now with the tangent of 2a, again that's going to be the tangent of a plus a. And if we go ahead and tangent of a plus a, the b's all turn to a's, this is a plus and that remains a minus. So what we come out with then is we come up with the tangent of 2a being equal to the tangent of a plus the tangent of a divided by 1 minus the tangent of a times the tangent of a. And we come up with 2 tan a over 1 minus tan squared a. Okay, and so there you go. That's how you can actually go about deriving the double angle formulas based upon the fact that we just assume that a is equal to b, and we apply the compound angle formulas. Now, let's go ahead and take a look at 2 problems, very similar looking problems, but the approach by which you actually solve these problems is going to be very, very different. So, let's take a look at problem number 1 and problem number 2. Here's problem number 1. It says sine of 2x is equal to cosine 2x. Problem number 2 says sine of 2x is equal to 2 cosine x. So notice there's only a slight difference, but the difference is very, very, very huge because of the fact that the 2 here is not associated with the x, but it's associated with the cosine of x. Now, if we wanted to go ahead and solve for this side here, being that the sine and cosine both have the argument of 2x, if I divide both sides by the cosine of 2x, I actually come up with the tangent of 2x is equal to 1. I can take the inverse tangent of both sides, plus pi k, where k is an element of z, and then I divide by 2, and I've got all of the possible solutions for this particular equation here. On the other hand, if we go ahead and take a look at problem number 2, what we're going to need to do is we're going to have to actually look to change this so that it's double angle representation. So here we go. Sine of 2x is the same thing as a 2 sine x cosine x. So there's the 2 sine x cosine x. I subtracted 2 cosine x from both sides because we need to go ahead and set it equal to 0. Because after that, what we want to do is we want to factor and then set each factor equal to 0. So what we come out with then is that we have the cosine of x is equal to 0. Of course, I divide it out by 2. And the sine of x is equal to 1. You take the inverse cosine here, you take the inverse sine here of both sides, and you can solve the equation here. So let's go ahead and wrap things up again. With the compound angle formulas, if you start off with that and assume that A is equal to B, then we can go ahead and derive the double angle formulas. Cosine of 2A actually has 3 different representations. Sine of 2A has 1 representation, tangent of 2A has 1 representation. What's going to happen then is that when we actually take a look at certain problems and trying to solve certain trigonometric equations, we're going to have to be very careful and look at the details as to how we want to go about solving that, and be very particular about when we want to go ahead and use the sine of 2x and the double angle formulas to go ahead and solve for particular equations. So that's the question that I have for you to think about, is when do I actually go about using these double angle formulas to help me, like in problem number 2, as opposed to this situation over here where I didn't have to use the double angle formulas. What's the difference, okay? So you're going to have to be very careful about some of those details, and we'll take a look at some of those examples in class the next time that we work together on some of these problems. Okay, so give it your best shot. We'll see how the double angle formulas work, and again, all based upon the compound angle formulas that you know. Okay, talk to you later. Bye-bye.